What's up, guys? Welcome back to another video. Today I'll be doing another LeetCode problem, and it's actually the first one in the LeetCode website. It's also the first one that I did, but back then when I first started this LeetCode, I was confused, no idea what I was doing. I kind of brute forced my way into it. I did the brute force method, which at that time I was just like, yeah, I solved it. That's nice, But like afterward, learning like what time complexity, learning that hashmap exists, I realized that my code in the past was pretty shit. So I'm gonna, do this one again. And plus this hashmap is a video. I did a video on that, so I'll be doing it on a LeetCode problem. So, it's pretty good. However, just in case, I will also show the brute force method first. It is very simple to do it. And then after it, I'll show the hashmap solution, which is the better version, obviously. Once again, I'll read the prompt, explain it, write out the code, and then explain it line by line. But this time, I'll be doing it twice, basically. So, number one, to sum, given an array of integers and an array of integers, nums, and an integer target, return the index of the two numbers such that they add up to the target. You may assume that each input have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So, for example, on the example 1, there's the array of integers 2, 7, 11, 15. Their target is 9, and the output is 0 and 1 because 2 plus 7 is 9. So we just return the index for the 2 and the 7. So let's first do the brute force method, which is kind of simple. You first have integer n for num's length. Afterward, I want to create a for loop that goes through basically the array. And I want to create another one inside. And I want this to be I plus 1. So the I equals 0 in that array will be the first index, basically. And then the j will be like I plus 1, meaning it's going to be on the second one. So I'll explain that once we get there. And then we have j less than n, and then j plus plus. And then if nums for I plus nums for j is equal to target, we just return the new integer array with the I and the j, like that. And then towards the very end, we want to return new integer with -1 and -1. And I'll explain that part too. So first things first, our target or our goal for this brute force, we're going to call it brute force, is that we want to, this is basically checking every pair for like I and j. And you can kind of see it. So for the I part, we start at 0, right? Which is 2. And for j, it's I plus 1, meaning it's 0 plus 1. So j starts at 7. What the to for loop is going to do is within the inner for loop, it's going to count, it's going to plus 1, basically. Checking to see if 2 plus 7 is equal to the target, 2 plus 11 is equal to the target, 2 plus 15. And if none of them return true, or basically if none of them return true for the if statement, then the outer loop, which is this, will be increased to 1. So that means we move on to 7. And then it's going to check 7 plus 11, 7 plus 15. None of them equals the target. So we move on to, so I becomes, for 3, which is, I becomes 2, which is the index for this array 11 here. And then it's going to do the same thing. So it's just going to, the for loop is going to keep going until it finds if there is a target that is equal. If there's the, any number in the integer, in the array that's going to equal to the target. So that's the brute force. And then, obviously, like, check if two elements add up to the target, which is the if statement. If yes, immediately return their index in a new array. And then for this part, So because the problem guarantees exactly one solution, the first time we find matching pairs, we're basically done. And so when we call this return, it's like a fallback return to satisfy the compiler. So in theory, this should never execute if the input follows the problem's like guarantee. Now for complexity, for the time complexity, it is very simple. What we have here is the for loop, which goes through O of n, big O of n, because it goes through n times, right? And then for the outer loop, the outer for, it's also n times. So both the inner and the outer runs n times. And so what you do is you have to multiply them together, because this one's inside this for loop. If it was like another for loop down here, and this one is down here, obviously it's not going to work, but at that point it'll be n plus n, not n times n. And so this works, but it's going to be really slow when the n is like really large. So it's better to do it with hashmap, which I will show. And okay, and then for the space complexity on this one, it's a big O of 1, because we only use a few variables. So let me run it real quick. Okay, seems good. Case 1, case 2, case 3, it runs perfectly. But when I submit it, I think it will show that like it's not optimal, basically. So we're gonna reset this and we're gonna do the hash map now. Now the hash map makes it where like instead of checking every pair, we scan the array one time. And for each number, for nums I, we compute what we need to reach the target, basically. So it's like, so what we're kind of doing is like complement equals target minus nums I. So we're looking for what this is. So we just get the target minus the nums I, and then we just, you know, and so, and like, yeah, I'm gonna read it out first actually, and then I'll explain it. So let me remove this. Okay, so let's first import Java for hashmap, and then afterward we want to import another Java, and this one will just be map. Now inside we're gonna have map, we're gonna have integer, and then another integer equals new hash map. Boom, boom, boom. Now we are going to create a for loop. However, unlike the brute force one, this for loop there's only one for loop for this one, because we only need to go through it once. So plus. Now we're going to have integer current is going to be equal to the nums I. We're going to have integer complement, which is target minus target from here minus the current from here. Now we're going to have an if statement. So if map dot contains key, then we're going to have complement. There we go. So complement here, and put it in here. Return new integer with the map dot get complement, and then I. There we go. Now after that, we put map dot put current I. Then towards the very end, we do return new integer. Again, this one's the same thing. -1. So again, for this one, it's like this basically kind of shows that like we will always guarantee, like we'll always find a solution before this. So it's like the previous one, you just have that there. Okay, so let me comment actually, because comment is always good. This is basically map from number value to its index in the array. For the for loop, what we do here is we're gonna loop through the array once. Like I said, there's only one for loop, so we just loop through it. Now for this part, this is where we check check if we've seen the complement before. And don't worry, I'll still explain more after this. And then if yes, we pretty much found the two indexes. And then this part will be otherwise remember the current value and its index. So I put the comment. If you don't understand, I'll explain. Don't worry. So first things first, we want to import the hash map and map so we can use the hash map data structure. Map is like the interface. Hash map is the concrete implementation. So for this part right here, we basically create a hash map, right? That maps the key and the value. So remember with my previous video on hash map, we have a key and a value. So the key will be the number nums. So the first part will be basically number num I. And then the value will be the index I. So like that. So if we want to know, like, have we seen value X before? We can check through the map contain key and get its index. And that's where we just need to go through like a single loop over the array from left to right. I will be the current index, and then current is the value of the index I, meaning let's just say it's 2. And then the complement is what we need from some other index to reach the target. So for example, since the target is 9 and our current is 2, so from here, target, I'm just going to write it out. I'm going to delete it anyway. Target is 9, and then the current, which is I 0, that's 2. When we get, then the complement will be 7. So then we ask the hash map, have we seen this complement value before? If yes, then map.get complement will gives the previous index j, where the nums j, so where nums j will equal to the complement, like that. That's how we do it. And now we're at index I. So nums j plus nums I will be complement plus current, which equals the target. Then that basically means we return this new indexes. And so for this part is basically, first index comes from the map. Second index is the current I. If we didn't find the complement in the map, we store the current value in its index, so it can be used as a complement for future numbers. And then, this part, again, is just for completeness. The problem says there's exactly one solution, so we should just return early, or we should return earlier in the loop. By the way, we only do this after, not this part, but we only do this after the check. So we only do this after the check, so we don't accidentally use the same element twice, just in case. All right, now, unlike the brute force method that I did, this one is, since there's only one time for loop, that means we pass through the array exactly once, which is big O of n times. And every contain keys or get or contain keys and put on the hash map, those are only big O of 1 average time. So in worst case scenario, we may insert almost all elements into the map. So, or basically, in worst case scenario, for the space complexity, is we may have to insert almost all elements into the map. So the extra space will be big O of n as well. So time, big O of n, space, also big O of n. But for space is worst case scenario, where we have to put everything in. for times where we have to go through the loop at least once. And the loop in the end just depends on how big the array is. Let's see. I can probably go through, like, walk through an example just in case. So, okay, let's go through example 1 then, just in case. So we start off with map being empty. And then I equals 0. So current is equal to 2. Now, what it's gonna ask is, oh, by the way, we need to do complement. I forgot. Complement equals 9 minus 2, so that's 7. Now here's what it's gonna ask: is 7 in the map? No, because map is empty right now. So what you want to do is you want to put the key and the value, and like I mentioned, the key is the number for nums I, and the value is index I. So what it's gonna kind of look like is something like this. So we have key here, and then value like this. So right now, what we're gonna put in the map will be 2, 0. Yeah. Wait. Yeah. 2, 0. Yeah. Gotta make sure, just in case. Okay, so there's that. Now we want to do I equals 1 because we basically loop through it and we check. Well, we loop through the first one. Now it's going to plus I. So now I equals 1. So I equals 1. Now current is equal to 7. Now it asks, and again, the same thing. Complement is still going to be the same thing. What it's going to do is it's going to check. But this time is 9 minus 7. And that equals to 2. So is 2 in the map? Yes, it is. It's in the map. So what you do is you just get. So map.get will be 2. And it's going to print out 0. Because 0 is the value. That's the one what we want. Then afterward, you just return 0 and 1. 1 being the I, and 0 being this right here. Complement being 2, and it's gonna print out 0 because that's the key and the value. So kind of like if you do like Python, it kind of looks like a dictionary in a way. So let me just remove some of the stuff because we don't need those anymore. I'll keep the comment, I guess, a little bit here. Test the result. Should say good. Nope, never mind. It does not say. Oh, I forgot. I need to remove this. Okay, there we go. Perfect. Now we submit, and it should be good. So going from brute force all the way down to something like this, hashmap, it changes from big O of n squared to just big O. So very easy, very nice. Thanks for watching.